Hello everyone. So this is MAT002 calculus. Now in this calculus, I'm going to be explaining how you are going to be able to answer questions without losing any points, without dropping points at all. Do you understand? Without losing any marks. Do you get that? Now I'm going to start from, look at these questions I have here. They are 2020, 2019. Of course, I've told you before that I'm working with 2020, 2019 and 2018 past questions. Do you understand? Now look at it. From first principle, find the y given that y equal tan x. So in reality, I have done that before in my video. Check the description box. Check the description box below. You are going to see the link to solve this tan x. So I'm not going to do it here again because I've solved that before. Yes. So it's actually raining, but don't mind the rain. So now, find the derivative of y equal e raised to power x from first principle. I have done that as well before. So actually, I have done a derivation from first principle for 10 functions, of which tan s is there, exponential s is there, even this one, s square is there. I have done that. Sin s is there. I have done that. So you just need to go and check those videos. I'm going to send you, or check the description button. And if you want to see all 10, all of them, all the whole 10, the link is also there. Do you understand my point? So please check it out and see how you can answer all these questions without losing any point. Do you understand? Without losing any marks. Especially if you don't know how to solve it before. Please go through it and check it. Know how to solve all these things very well. Do you understand? You can see this is 10 marks. Don't forget, each question is 15 marks. You know, each of the parts, you know, your upper parts, pure mathematics, calculus, applied maths and statistics, and you answer one from each of them. So if you go through all those pure mathematics one I did, there's no way you will not be able to answer one. That is why I want just at least what you see in my video, know it. If you know it, I'm very sure that you'll be able to answer most of the objective questions and the theory question, because of course, the one I'm going to use calculator that you can use calculator for in the calculus, I'll also do this video on that one as well. Do you understand? But all this one are theory. You need to show you need to show working, you need to show details. Do you understand? So that is what is happening here. Do you get my point? So e raised to power x, I've done that. Now also look at this. This is 28. This is 5 marks. This is 2018 question as well. Question 3a. From first principle, find the derivative of f of x equal s squared plus sin s. I've done that too before. So go and check it, and it's well explanatory. Do you understand? Even reduction formula for all three functions, I have done that as well. So go and check it. Do you understand? Now I've not done this one. So now let's do 2020 question 7b, which is 8 marks. They say use first principle of differentiation to derive quotient rule, and hence find the first derivative of this. Now we want to derive this. This is quotient rule. No, if y equal u over v, then y dx is v du dx minus u dv dx all over v squared. That is what they call quotient rule. Do you understand? Now I want to show you something before I start it. Now the y dx is what? On first principle, the y dx is equal to limit as what? Delta x goes to 0 of f of x. No, y is a function of x. F of x plus delta x minus f of x all over delta x. You understand? That is what we have. That is for this one. Now, let me now take v. If v is a function of s too, obviously it's a function of s, but let's say v is a function of s. dv dx, we actually have to be equal to limit as delta x goes to 0 of v of x plus delta x minus v of x all over delta x. So please take note of that. This is the v dx. Similarly, the u dx is limit as delta x goes to 0 of u x plus delta x minus u of x all over delta x. All these three things are going to be very useful. They are going to be very useful in this derivative. So now let's get started. I have y is equal to u over v. Now, you know, from first principle, add increment to both sides. That is the first thing to do. From first principle, add increment to both sides. Y plus delta y is equal to this one to add increment. This is a function of s. You have u of s plus delta s all over v of s plus delta s. That is what you are going to have, right? If you check my video on first principle, you would have gotten used to it. Like, whenever you want to do first principle, the first thing to do is you add increments to both sides. Do you understand? So that's what I have done. Then bring this y to the other side so that you will be left with delta y is equal to u of x plus delta s all over v of s plus delta s minus y, right? But y is u over v. Y is equal to u over v. So write u over v, right? So now find the LCM. Delta y is equal to, I have v, right? V of x plus delta s multiplied by v. That is the LCM. So this one divided by this, you will left with v. So v times this, you have u of x plus delta s, right? Can you see what I'm doing? V will multiply it, v multiply it, right? Minus this one divided by this one, u will cancel to remain u. Maybe I should write the v in front. I'm sorry, let me write the v in front. So it's still the same thing anyways. 3 times 4 and 4 times 3 will give you the same answer. U multiplied by v s plus delta s. Can you see that? We are getting closer to the answer small. So what is the next thing I'm to do now? The next thing I'm to do now is that I will do something. Look at what I have. You know, I want to get the UDS. You know, look at, let me show you what you are doing. This is v, right? I want to get the UDS, but I just have US plus ds. But the UDS is what? US plus ds minus u of x. So I will add it. Look at what I'm going to do. Delta y is equal to v u s plus ds minus, you know, v is here. I have to factorize it, so I have to do v u of x. Do you get that? You know, since I have put u of x, if I write u and u of x, they are the same. See, I have added something that is not there, minus u of x, right? So let me use another pen tool so that you can get it. Minus v of vu. I've added, this one is not there before, but I will add it back. Minus vu plus vu will give me 0. So then I'll be left with what's it called? Then this one is still there. Minus uv x u of s plus delta s, right? All over v s plus delta s v. That is what I'm going to have. Are you getting my point? That's what I'm going to have. So now, look at what happened now. Factorize v out here. So delta y will be equal to factorize v. When you factorize v, you will be left with u of s plus delta s minus u of s. U of s is still the same thing as u. Maybe I should write u of s because of what I want to use this for. Do you get my point? Now, that is for this one. You know, minus ub plus ub is out. I'm back to this one, so I have not changed anything. So this is what I have. Then u is common here as well. You can see u is common, u is common. So plus u. I'll be left with what? V minus v of s plus delta s all over v of s plus delta s v. That's what I have. So let's continue. Are you getting my point? Let's continue. Now, this is what is going to happen now. Delta y is equal to v u of x plus delta x minus u of x. Now, if I bring out minus from here so that this one, see, just be looking at where we are going to. This is minus. I have plus here, so bring out minus. Minus u. So when you bring out minus, it will swap. That is, you first have v of s plus delta s, right? Minus v. That v, I told you, is still the same thing as v of x, isn't it? Now, all over v of x plus delta x v. Do you get that? Now, so in first principle, number one is that you will add increment. Number two is that you will subtract y from it and simplify. So the third thing to do is that divide both sides by delta s. Now, this one will now be delta y over delta s, right? Do you see what I'm saying? Do you understand what I'm doing? Delta y over delta s. So all this one too will now be all over delta s. Look at it. It will now be 1 over delta s, multiplying all these things, v of u s plus delta s minus u of s minus u v of s plus delta s minus v of s all over v s plus delta s multiplied by v. That is what you are going to have. Now, what next? Instead of allowing this one to come down, let it come up. Let it multiply the up. Let it multiply the up. Do you understand my point? Though I say this one is fast. Look at what I'm going to do now. It's still the same thing. All this up one, v u of x plus delta s minus u of x minus u v of x plus delta s minus v of x, right? I'll divide everything by what? Delta s. Multiply by 1 over all these ones. Multiply by 1 over v of x plus delta s, then v. Do you get that? That is what I have done. Now, to round off, separate it. You know how to separate fraction now. This one over all this one is multiplying everything, right? Now, this one will have all this one over delta s, so this one will have v. Now, look at what I'm doing. U of x plus delta s minus u of x all over delta s. This is correct. It's like when you have 3 plus 4 all over 5. This is the same as 3 over 5 plus 4 over 5. If you don't believe, press 3 plus 4 divided by 5 and then press 3 over 5 plus 4 over 5 on your calculator, you will get the same answer. So this one is like, all this one is like 3 minus 4 all over 5. So it's same as 3 over 5, which is, and I decided to bring the v out, 3 over 5 minus 4 over 5. Do you understand? So u of, the same thing happens to this one too. V of s plus delta s minus v of s all over delta s. Do you get that? Multiply by this one that I push out. Do you get that? Multiply by, let me write it here, 1 over v of s plus delta s multiplied by v. That's what you have. Now, delta y over delta s is equal to what? So, that's what we have. So, it has lots of generality now. Listen again. Whenever you are dealing with first principle, add increments to both sides, subtract y and simplify, then divide by delta s. After that, the last thing to do is to take limit as delta s goes to 0. Limit of both sides as delta s goes to 0 of both sides of delta y over delta s. The same thing happens to this one, limit as delta s goes to 0 of all these things, v of u s plus delta s minus u of x all over delta s, right? Then minus u v of x plus delta s minus v of x all over delta s. Now, that's what I have. Don't forget this last piece. Then we write it under again. Multiply by 1 over v of s plus beta s multiplied by v. That's what I'm going to have. So now, to finish what we are doing, so now to round off, whenever you take limit as delta s goes to 0 of delta y over delta s, it changes to dy dx. It becomes dy ds. Limit as delta s goes to 0. Don't forget what I told you earlier. This thing will enter everything. Like this limit as delta s goes to 0 is for this one, is for this one, is for this one. So when you have limit as delta s goes to 0 of u of s plus delta s, don't forget what I write. Maybe I should write so that you can recall very well. I said that the u ds is equal to what? Limit as delta s goes to 0 of u of s plus delta s minus u of s over delta s. So this is what it is. Do you get my point? So now look at it now. Limit as delta s goes to 0 of this one. This is exactly, so this is v du ds. That is my point. So I will have v du ds. Maybe I can still put it in a bracket. Minus. Then I have you. When this limit gets to this one, limit as delta s goes to 0 of v of s plus delta s minus v of s over delta s. So that will become minus u dv ds multiplied by 1 over this one. Anywhere you see delta, for this case, anywhere you see delta s, put 0. So you'll be left with v of x multiplied by v. And v of s is still the same thing as v. So I'll be left with v of s times v, which is v squared. So dy ds is equal to v du ds minus u dv ds all over v squared. That is what you are going to have, and that is the proof of the first of that question. Do you understand? Right? So please, you can go through it again. You can go through it again until you get it, so that if it come out in your exam, you will be able to answer it. Do you understand my point? Now, let's continue. The next one now is, they now say I should find the first derivative of this. So I have y is equal to e raised to power cos 3s all over cos s. So because of what I have done here, I'm going to use I'm going to use this quotient rule to solve this, to find the y ds. So in this case, you can see this is my u. Let u be equal to e raised to power cos 3s. And v be equal to cos s. Do you get that? I will now find the UDS. Now, to find the UDS, look at it. When you have e raised to power something, if you want to differentiate e raised to power something, differentiate the power. Differentiate the power. Differentiate cos 3s. You know, when you want to differentiate cos, the answer is minus sign, right? Do you understand? Now, if you now want to differentiate 3 cos 3s, do like as if it is cos s that is there. Differentiate cos s, you have what? Minus sine s, but it's not s that is there, it's 3s. Times, differentiate this 3s. Do you understand? Like cos s, the answer is minus sine s, but it is not x, it's 3s. It's obvious. So that's why you write sine 3s. Then multiply by, differentiate that thing you call s, differentiate 3s. What is the answer? The answer is 3. So the answer is minus 3 sine 3s. Listen to it again. Now do as if it is cos s. Do you get that? Differentiate it. The answer is minus sine s, but it is not x, right? It's minus sine 3s times, then that thing you do as if it is s. Differentiate that thing. Differentiate 3s, the answer is 3. So the answer is minus 3 sine 3s. So this is minus 3 sine 3s. Now look at what happened here. I want to differentiate exponential. If you want to differentiate e raised to power something, I told you look at the power, differentiate the power. This I've differentiated the power, the what next? Write the question back. E raised to power cos 3s. That's all. You are done differentiating this. Now, this one that we are talking about, dv ds. If you differentiate cos x, you have minus sine x. So your knowledge of differentiation and integration should be very sound for all these basic one. Do you get my point? At least to a certain level. I hope you do understand what I'm saying. When you differentiate cos x, you have minus sine x. That is what you have in this case. Now let's continue. So the y ds is equal to v du ds minus u dv ds all over v square. V is what? Cos x. Multiply by du ds. Du ds, this is du ds. Minus 3 sine 3s e raised to power cos 3s, right? Minus u. This is u. E raised to power cos 3s. Multiply by, you see what I'm doing? I'm just using this formula we just derived. V, this is v cos x. Du ds, this is the answer, right? Minus u, this is u. Dv ds, this is minus sine s. All over v square. V is what? Cos square what? S. You know, v is cos x. V square is cos x all square, which is same as cos square x. Now to finish this one, particular question now, the y ds will be equal to, open the brackets, this is minus 3 cos s sine 3s e raised to power what? Cos 3s minus will give me plus sine s e raised to power cos 3s all over cos square s. That's what you are going to have, and that's the answer. Or you might like to factorize e raised to power cos 3s. Whichever way you are doing it is fine. Just make sure you get a point. Do you understand? So please go through it again if you don't understand it clearly. And whenever you see a question like this, know that you will use the quotient rule. Do you understand? So, and that's all for, you can see how first principle come out. So in case first principle come out again, you should be able to answer it. Do you understand? Don't forget those videos I talk about that I've done before for all these other ones. Please check them out. Do you understand? Thank you very much. And if you have not subscribed, please click the subscribe button. So now in this case, this next question I have written out is on differentiation. All the differentiation questions that come out in the theory aspects. Look at 2015 question 5b. It came out in 2015 question 5b. Find the y ds if y cos x plus cos s e raised to power 2y equal s cubed minus 2s squared plus s minus 2. What this one is telling you, or what you should notice, is that most of the, when they ask you to find the y ds in theory question, most of the time it is an implicit function, that is x and y will be combined together. Don't worry, I'm going to show you how you are going to differentiate. The same thing to find the y ds. This is 2026b. This is 4 marks. You can see 3x squared y plus xy squared equal 5. Now look at this one. Find the differential coefficient of, this is 2019 question 3c, of y equal 3x squared sine 2x. You can see this one. This one you will see how we are going to solve it as well. Then lastly, now this is a parametric equation. Let the parametric equation of the curve C be given as, this is 2018 question 3b, this is 2018 question 4b. If x, y minus this equal this, find the y ds at this point. Now, before I start, I just want to do a quick revision on trig function, like on trig derivative. This y prime you are seeing here means the y ds. Another way they write the y ds is y prime. Do you understand? They write it as y prime. Now, if y is sin s, differentiate sin s. When you differentiate sin s, that is the y ds or y prime. Y prime, when you see y prime, it means the y ds. Y prime equal cos s. That is, whenever we are differentiating sin s, the answer is cos s. Whenever we are differentiating cos s, the answer is minus sine. When you are differentiating tan, the answer is sec square s. When you differentiate cot, the answer is minus cosec square s. When you differentiate sec, the answer is sec s tan s. When you differentiate cosec, the answer is minus cosec s cot s. Do you understand? So that is what you are going to talk about here. Do you get my point? Now that is what we have. So please take note of this. You have to be able to remember it in case you are asked to differentiate a trig function. Do you understand? Now this one, find y ds if y equal this. Now let me tell you one thing you need to note. Whenever you are differentiating y, you must add dy ds. Do you understand? Whenever you are differentiating y, you must add dy ds. Now let me show you how you will differentiate now. This is a question now. By differentiating, you know, I have y cot s. You will differentiate the two. You will differentiate y, you will differentiate x. Do you understand? Look at what we have for only this one. Now let me even open a bracket for it. Take y, differentiate cot s. You know, you have two things. Now don't worry, I'm going to show you another way of differentiating this, but listen to this one first. When you take y, you know, I've written y back, leave it. Differentiate the second one. If you differentiate cot s, what is the answer? Minus cosec squared. You have to be able to remember because all this one will not be there inside your examination booklet. Do you understand now? Differentiate cot s, the answer is minus cosec square s. Multiply by it, minus cosec square s. That is what I have. Now, plus. I'm still there, plus. You know that I take y out, right? I differentiate the second one. Now, take the second one, cot s. Differentiate the first one. What is the first one? The first thing is y. When you differentiate just y, the answer is dy ds. Whenever you are differentiating y, the answer is always dy ds. So this one will be dy ds. So in reality, all these ones I've written is just only this one. Do you get that? Now, plus, this is also two things. This is cos s. See, this is number one, cos s, number two, e raised to power sin s. The same thing we do for this one though. Whenever you have two things, now look at it again. Take the first one, keep it. Cos s. Now differentiate the second one. You know this one too. I take y, keep it, differentiate the second one, right? Plus, now take the second one, differentiate the first one. That's all. Now the same thing happen here. Take the first one, differentiate the second one, e raised to power 2y. Now, the first thing is that assume it is e raised to power 2s. How do you differentiate e raised to power 2s? If you differentiate e raised to power 2s, what is the answer? I told you before that whenever you want to differentiate e raised to power, e raised to power exponential, the power, differentiate that power. Do you understand? Differentiate 2s, what is the answer? The answer is 2. Write the question back. E raised to power 2s. From e y, we are differentiating e raised to power 2y. You see the way we differentiated e raised to power 2s, that's the way we are going to differentiate e raised to power 2y. Differentiate it normally. So the answer will now be 2 e raised to power 2y. You know, don't forget it's not y, it is x. But then, don't forget, I differentiated y. Whenever you differentiate y, add dy ds. So if you differentiate this one, so it's 2 e raised to power 2y dy ds. Do you understand? Differentiate it normally. Go ask if this one is x. The answer. When you get the answer, change the s back to y. 2 e raised to power 2y. Then put the y ds to show that it is y you are differentiated. So this one will now be 2 e raised to power 2y dy ds. Don't forget I'm still here. Take the first one, differentiate the second one. This is the answer. Plus, take the second one now, e raised to power 2y, differentiate the first one. The first one is cos. Differentiate cos x. The answer is minus sine. I don't want you to be looking at this again, but if you don't know it, please memorize it. Memorize it. Memorize it. It is important. The answer is minus sine s. Minus sine s. That's what you are going to have. Is equal to, then differentiate s cubed, 3x squared minus Differentiate 2s, don't forget, maybe you don't know how to differentiate s cubed. This is s. The power is what? 3. Let that power come down. When the power comes down, write the question. S raised to power 3. Then subtract 1 from the power. So this is 3s squared. So that's how we did. I got 3s squared. Now, for this 2s squared, let me do it again in case you don't know how to get it squared. Maybe you don't understand it clearly. The power, this s you are looking at, the power of s is what? 2. Bring it down. Let it come down. 2 times, write the question. 2s squared. But subtract 1 from the what? Power. So this is 2 times 2, 4s raised to power 1, which is the same thing as 4s. So this is 3s squared minus 4s, right? Differentiate s, that's s raised to power 1. Do like this, you will get the answer. The answer is 1 plus 1. If you differentiate a constant, the answer is always 0. Do you get that? The answer is always 0. So what is the other method I was talking about in this place? No, I told you that I'm going to do another method now. The other method is just like this. It's a product rule. You know, when you have y equal uv, the y ds will be equal to u dv ds plus v du ds. So it's more or less like saying, take the first one, this is it, differentiate the second one, then take the second one, v, differentiate the first one. That's all. It's just a product rule. Do you understand? You can use product rule to differentiate that as well. Now, open the bracket and then let's finish. Let's round up this question. Why we multiply this one? So I have minus y cosec squares plus this one will be cos x dy ds. Can you see what I'm doing? Plus open this one too, plus cos s, no, 2, let the 2 come to the front, 2 e raised to power 2y plus s dy ds, then plus times minus will give me minus e raised to power 2y sin s, and everything will be equal to 3x squared minus 4s plus 1. So now take all the divide ds, like let all the ones that have divide ds stay in one side. All those ones that does not have divide ds, let them go to the other side. So this one has divide ds and this one has it. So let it remain at the left hand side, so that I will have cos s dy ds plus 2 e raised to power 2y cos s dy ds, right, is equal to, now all this one is coming here, this one is coming here, this one and this one that is here, we come to the other side, right? But something is at the other side first. 3s squared minus 4s plus 1 is here before, right? So let this one come here to become plus y. Are you getting my point? Plus y cosec square s, that's what I will have. This one too will come to the other side, plus e raised to power 2y sin s. Factorize the dy ds here. I'm almost rounding off. This one will remain cos s plus 2e raised to power 2y cos s dy ds is equal to all these things at the right hand side. What's at the right hand side? I have 3s squared minus 4x plus 1 plus these two things. Let me write it here, plus y cos cosec squared plus e raised to power 2y sin s. That is what you are going to have. Now, divide both sides by this, all these things. Divide it by all these things to get your final answer. So that the y ds will be equal to 3s squared minus 4s plus 1 plus y cosec square s plus e raised to power 2y sin s all over this one cos s plus 2e raised to power 2y cos. And this is the answer. That's the answer to that question. Let us answer the next one. Now, the next one is so now the next one, let's see what will happen to the next one. So for the next one, this is also question 2020, question 6b. 2020 question 6b. They say find the y guess if 3x squared plus xy squared equal 5. You want to find the y guess of this one, 4 marks. Now, the same way we have done for this one, that is how we are going to do for this one too. This one will be like, this is the first one, this is the second one. Do you understand? The same way, similarly, to only differentiate this one, take the first one, 3x squared. Differentiate the second one. The second one is y. Don't forget I told you, whenever you are differentiating y, you have what? The y ds. The y ds. Plus, take the second one now, y. Differentiate the first one. Differentiate 3x squared. I've told you, 3x squared. Try it by yourself, especially if you don't know it before now. Let these two come down. 2 times, write the equation 3x squared then minus 1. 2 times 3 is 6x raised to power 1, which is 6x. Do you understand? So this is 6x. Do you understand? I've just done only this. Plus, the same thing happens here. The first one, write it. Differentiate the second one. You know the second one is what? Y squared. The second thing here is y squared. Right? Do as if it is x squared. I've told you before. Differentiate x squared. The answer is what? 2x. But don't forget, it's actually y squared I'm differentiating. So the answer will be 2y. But whenever you are differentiating y, what must you add? The y ds. So this is s, then multiply by 2y dy ds plus, are you with me? Take the second one now, y squared. Differentiate the first one, 1. I hope you are getting it. Back forward again, backward it to see again, like to recheck what I have done. Is equal to differentiate 5. Whenever you are differentiating a constant, the answer is always 0. So this is 0. And don't make the mistake of differentiating only the left hand side and say the answer is still 5. Please don't make that mistake. They will not pity you. They will remove your marks as if you've done something big. Actually, it's big in mathematics anyways. So this is the answer. Open the bracket. This is 3x squared dy ds plus y times 6x. That is 6xy. Right? Open the bracket here to plus 2xy dy ds plus y squared is equal to 0. So the same principle we apply here, we are going to apply it. Let all the dy ds stay at the left hand side. Transfer every other thing to the right, to the other side. This one has dy ds. This one has dy ds. So every other thing is moving to the other side. So you have 3x squared dy ds left here plus 2xy right dy ds. So you'll be having minus 6xy minus y squared. That's what you have. Factorize dy ds. This one will be having 3x squared plus 2xy dy ds is equal to minus 6xy minus y squared. Right? So the y ds will be equal to what? Minus 6xy minus y squared all over what? 3x squared plus 2xy. That's what we are going to have. So that's the answer to this to the second question. Now let's go to, you can see 2019 question 3c. That's 3 marks. So 2019 question 3c. What will happen here is that this is question 3c. Y equal 3x squared sine s. The way we are differentiating this, that's how we are going to differentiate it, but then just use square product rule so that you don't lose any marks. Let me tell you, the idea is that keep this one, differentiate the second one like we normally do here, then plus, keep the second one, differentiate the first one. But I told you so that you don't drop any points. What they want you to use here is product rule. Do you get that? So you will say let u equal 3x squared. You can see they are multiplying themselves. So how do you know they want to use product rule? They will make it obvious that you have two different functions multiplying themselves. Then you know that you are going to use product rule. Do you get my point? So now let u be 3x squared and b be equal to sine x, right? Differentiate. The u ds is equal to 6x. Differentiate this one. You know how I got this, right? I've done that before here. 6x. Now the v ds, and please, if you don't know how to differentiate very well, as I'm differentiating, be trying it on your own too. Be trying it on your own. Follow what I have done, like you will get it. Differentiate sine s, you have to remember now cos s. So what is product rule? You have to remember that one as well too. The y ds equal u the v ds plus v the u ds. What is u? U is 3x squared. The v ds is cos s plus v. V is what? Sin s. The u ds is 6x. Open the brackets. This is 3x squared cos s. This one will be plus 6x. Don't go and write sine 6x squared. This one is angle. This one is no angle. Let it stay at the back. 6s sine s. Do you get my point? Don't write sine 6x squared, please. Take note of that. You see that this one, so you can't see this is cos 3x cubed. Take note of that. Thank you very much. That's the answer to this question. The next one, 2018. This is 2018 now. Question 3b. So look at this one. You are told something. Let the parametric equation of a curve C be given by y equal t squared over 1 plus t squared, and s equal this. Find the y ds. It is very simple. You are giving y to be t squared over 1 plus t squared, and you are giving s to be equal to what? Sine 4t squared minus 3. Then actually you are now told to find the y ds. To find the y ds in this place, let me tell you what you are going to do. Y is a function of t, that is what you are given, and s is also a function of t. Remember chain rule. The y ds will be equal to what? You can find the y dt here because that's what you have. The y dt, then multiply by, you can find the s dt, but then you can take the reciprocal dt ds. So the y dt multiplied by the t ds, that is the y ds. So that is how we are going to get this answer. So now we differentiate this one, the y dt with respect to t, differentiate this one with respect to t as well, the s dt, then we find this. Right? Now let's do that. Now, our rough solution. Now, from y equal t squared over 1 plus t squared. So in reality, what is very good for you to use is quotient rule, right? Let u be t squared and b be what? 1 plus t squared. Differentiate it. Du dt, don't go and write the u ds. So this is now a function of t. You are differentiating with respect to t, so you'll be writing t or s, t or x. Do you get my point? The u dt is what? 2t. The v dt is also 2t, right? Now the y, don't forget this is quotient rule. So the y ds for quotient rule is what? V du ds minus u dv ds all over v square, right? What is v? 1 plus t squared. Du ds 2t minus u. What is u? T squared. dv ds 2t all over v. V is what? 1 plus t squared all square. So what will happen after that? Open this bracket. This one will be 2t plus 2t cubed. 2t times 1, 2t, 2t times t squared, 2t cubed minus t squared times 2t, 2t cubed all over what? 1 plus t squared all square. So now dy ds is equal to 2t cubed minus 2t cubed will give me 0, so you'll be left with 2t. 2t over 1 plus t squared all square. That's the y ds. That is the y ds. That's the y. Rubbish with confidence. That is the y dt. Oh, the y dt. Don't forget the y dt. I want to write the y dt. Did you get my point? So the y dt. So I've gotten the y dt. It remains the t ds. So now, what is s? S is equal to sine 4t squared minus 3. Sine 4t squared minus what? 3. How will this one help you differentiate? Now, don't forget, I was saying something the other time. Let me tell you, let me show you shortcuts, then we can use actually what we are going to use here is chain rule, but then let me show you one shortcut now. You know, do as if, no, this is sine 4t squared minus 3. Do as if it is sine s. If differentiate sine s, what do you have? You have cos s. No, you have cos s, but it is not s. What is there? 4t squared minus 3 times differentiate what is here. You know, don't forget we are differentiating with respect to t. So sine s differentiate sine s, you have cos s, that is cos 4t squared minus 3 multiplied by differentiate what is inside. If you differentiate what 4t squared, you have what? 8t. Differentiate a constant, you have 0. You know, it's just like differentiate 8s squared. So the answer will now be 8t cos 4t squared minus 3. You can even write it actually. You can write this one down, or you use chain rule. Chain rule is still the same thing. Like you can use chain rule to solve that. Now you can write it down. Please take note of that. Especially if it comes out in objective, you can do that. Even in theory, you can do that. But I don't know. I don't just want to do that. I want to do this in case you don't know how to use chain rule. That's why I want to use chain rule. Do you understand? Let u be equal to 4t squared minus 3. You will now do du dt. Du dt means that, you know, assuming it's y that I say, you will write dy dt. So it's u that I say differentiate u with respect to t. Differentiate this one out. It's like 8s squared. 8s squared will give 4s squared. 4s squared will give me 8s. So do as if it's s, differentiate 8s, but it is t. Differentiate a constant, you have 0. So that means s will now be equal to what? Sine. I know I've let you to be 40 squared minus 3, so it will be sine. You differentiate, you know, this s here with respect to what? U. ds du. This is cos what? U. And what is u? Replace u back, 40 squared minus 3. So what are we looking for? ds dt. No, ds dt is what we are looking for. So ds dt will be equal to what? ds du, that is chain rule, times du dt. That's what we call chain rule. So now, to round this off, or to complete this question, what will happen is that ds du is what? ds du is cos 40 squared minus 3 multiplied by the u dt. The u dt is 8t. Right? The u dt is 8t. Now, see what will happen multiply it, you have 8t cos 4t squared minus 3. That is what you are going to have at the end of the day. That is the answer. Now, don't forget, what are we asked to find? Dy dx. We find dy dt, we found the s dt. So, this is the s dt. So, reciprocate, we reciprocate dt ds, that is, this one is over 1. So, bring the denominator or bring the numerator down. So, this one too will be 1 over 8t cos 4t squared minus 3. That's what you are going to have. So now the y ds that you asked us to find, the y the what? dt times dt, and the y dt is 2t over 1 plus t squared all squared. The TDS will be this one, 1 over 8t cos 4t squared minus 3. So what you will just notice is that t can cut 2 here 1, 2 here 4. Do you get? So what you will left, let me just manage here to write the answer. This one will now be 1, that is only one that will remain at the numerator. Then 4 is here, 4, 1 plus t squared all squared cos 4t squared minus 3. So I suppose this question is to waste your time, but then you quickly use, actually, you are supposed to quickly use quotient rule fast. This one you can just differentiate the first one I showed you, then get this answer. Do you understand my point? So that's the answer to that question. Now let's see. Let's do the last one on differentiation. The same thing. So now look at this one. I have xy minus sine xy equals 3. I want to differentiate this. Don't forget implicit. So now equal 3. Now this is xy. For this body, this one, take the first one x. Differentiate the second one. Differentiate y. When you differentiate y, what is the answer? Dy ds. Plus take the second one y. Differentiate the first one 1. If you differentiate s, the answer is 1. I'm done with that one. Minus. Now see this one, sine xy. Open the bracket for that one. Sine xy. Do you get that? How am I to differentiate this one now? So how am I to differentiate this one? Take the first one, s, right? I have xy here. Now, I'm looking for a way to explain to you that you understand very clearly. There are two things, x and y. If you take the first one, take it. But don't bring it out because it's not standing alone, it's inside sign. Do you get that? Differentiate the second one. If you take the first one, actually look at what I'm trying to say. This first one, you do as if it's a constant. Imagine you want to differentiate sine 3s. Do you get that? Do you get that? Now, let me explain now. I know how I'm going to explain sine xy. Right? Do as if it is one that is here, s. Now, don't forget there are two things. The way I was doing for this one, I do as if it's one thing, then you differentiate it now. Do as if it is one thing that is here. If you differentiate now, you have to differentiate with respect to x and with respect to y. That's what we have been doing since, right? You take the first one x, differentiate the second one, the y ds, plus now take y, differentiate x. So in this case, you keep s, differentiate y. The second one, you keep y, differentiate s. The same thing, you keep s, differentiate y, you keep y, differentiate x. Do you understand? Do you get that? Now, that's what we are going to do here as well. So I have sine xy. Do as if it's one thing that is here, right? But differentiate sine s. What is the answer? Cos s, Abi. The answer is cos s, but it is not s that is there. What is there? Sy. Multiply by, now differentiate with respect to s. If you differentiate with respect to s, this one will be 1. If you differentiate s, the answer is 1. You'll be left with y. That's what you have. Do you understand what I'm doing at all? Sin sy. Do as if it is one thing that I say, s sin s. Differentiate sin s, the answer is cos s, but it is not s that is there, it is sy. So the answer is cos sy. Times, you will differentiate what is inside there, but what is inside there is two things, two variables. You have x and y there. So you will first differentiate with respect to x, get the answer, differentiate with respect to y, get the answer, and you put it inside the bracket. Did you understand? You know, you normally get one answer for any implicit derivative like this. That's what I'm talking about. Sin s, I mean differentiate it cos s, but it is not s, you have xy, times differentiate with respect to s. If you differentiate s, the answer is 1, but it's that 1 times y. Do you understand? So that means someone will give me, don't go and write cos sy square. I used to say that y will come to the back, y cos sy. So I will have y cos sy. The same thing now I have done. See, what I have done is just for x. Now for y, the same thing. No, differentiate this one, you have cos s, but that's cos sy. Multiply by, differentiate this one with respect to y, nothing concerns s. Differentiate y, the answer is what? Dy ds. Whenever you are differentiating y, the answer is dy ds, but s is ds, so times s dy ds. So this one will now be s cos sy dy ds. That's what I'm going to have. So this one will be plus s cos sy dy ds. Don't multiply x square y. It's equal to, don't forget I told you, you even differentiate what is after the equal to. It's equal to differentiate 3, the answer is what? 0. Thank you very much. So now what do we do now? What do we do? What do we do? So now I'll put the bracket, this is s dy ds plus y. This is minus y cos sy. Take note of the minus so it will multiply everything. Minus s cos sy. Let all the dy ds stay in one side, and let all the one that does not have the y ds go to the other side. This one has the y ds, this one has the y ds. This one and this one has the y ds. Let them stay. Then this one to the other side. This is s dy ds minus s cos sy dy ds is equal to, let this one come here, it become y cos sy minus y. Factorize the y ds, this one will become s minus cos sy dy ds is equal to y cos sy minus y. So the y ds will be equal to y cos sy minus y all over x minus cos xy. That is the answer we are going to have. Now don't forget, find the y ds at 1 comma pi over 3. So at 1 comma pi over 3. Pi means 180. Pi means 180. 180 divided by 3 is 60. So this one means pi comma, this one is x. X is 1. Y is pi over 3. So that means the y ds, anywhere you see s, put 1. Anywhere you see y, put pi over 3. It means that the y ds will be y. Y is what? Pi over 3. Pi over 3 cos 1 times pi over 3 is pi over 3. Or that's cos 60. Minus y, that's also pi over 3. All over s. S is 1. Minus cos pi over 3. Because 1 times pi over 3 is 1 over 3. So pi over 3. Cos 60 is 1 over 2. Because pi over 3 is 60. Cos 60 is 1 over 2. So pi over 3 times 1 over 2 will give me pi over 6. Minus what? Pi over 3. That's what you are going to have. All over 1. Minus cos pi over 2 is cos pi over 3. That's cos 60. Cos 60 is 1 over 2. Calculator can do that for you anyways. It will write the answer for you. You just need to know that pi is 180. Right? So pi over 6 minus pi over 3, do LCM. When you do LCM, this is what you are actually going to have. The y ds is equal to, at the numerator you'll be left with what? Minus pi over 6. That's what you are going to have. At the denominator you'll be having 1 over 2. So this is minus pi over 6 times 2 over 1. Or just first calculator you will get it. Like this one will become minus pi over 3. So the y ds at this point is minus pi over 3. And that's all for this question. Please take note of that and check it well. It might be tiring, but then you need to pay, like you need to put in effort. Do you understand? So please subscribe to my YouTube channel for to encourage me, please, and share to your friend. If you have downloaded this video and you are watching it now and you have not subscribed, please, I beg of you, go back online and type President Math on YouTube and please subscribe to my YouTube channel. Thank you very much. Find and classify the stationary point of the curve y equal x cubed minus 2x squared minus 4x minus 8. 7 marks. That's 2020 question 7C. 2019 question 4A. Obtain the expansion of e raised to power x sin x in the ascending power of x as far as the term in x raised to power 5. Now show that this is a solution to this differential equation. This is 2018 question number 4A. Now let me tell you something. So for stationary point, they say find and classify the stationary point. To get stationary point, the y ds must be 0. That is the first thing you need to take note of. So we want to differentiate this one. The y ds, differentiate x cubed. The answer is 3x squared minus 4x minus 4. Differentiate a constant, the answer is 0, so you don't need to write that. So at stationary point, at the stationary point or at turning point, they call it turning point, the y ds equals 0. So again, if you are told to find minimum point or maximum point or point of inflection, this is how you are going to do it. Differentiate it, equate what you get to 0 and solve for x. So in this case, I'll solve for x. So I have 3x squared minus 4x minus 4. So at this junction, what happened is that what will happen here is that you will solve the quadratic equation. You can use calculator to solve that. I've already teach you, or I've done it in another video, how to solve with calculator, like how to solve quadratic equation using calculator. So this is what we have here. So this is 3x. Well, let me just factorize. Minus 6x plus 2x minus 4 equal to 0. So factorize. I'm using factorization method. You can use calculator to solve this one. Just for solving the quadratic equation, we'll obtain this. Or use factor. If you know how to solve quadratic equation using factorization method, use it. Or using formula method, solve it. Do you get that? So 3x is common here. I have x minus 2. 2 is common here. I have x minus 2 equals 0. So x minus 2 is common. So I have 3x plus 2. X minus 2 is equal to 0, right? So x will be equal to minus 2 over 3 and 2. That is the answer I have here. Minus 2 over 3 and 2. So that is the find. So this is the answer. This is the turning point. But I just find the C. They say find and classify the stationary point. This I just find the stationary point, but I have not classified it yet. How do you classify stationary point? You have to tell us which one is the minimum point, which one is the maximum point, if there exists, if it's there, or which one is the point of inflection. Like in this case now, I've already given you the condition in case you have forgotten or maybe you don't know. you will differentiate the second time. What I wrote here is what I've written here is very important. The square y over the x square, when it's greater than 0, you will see what it means. If this one is greater than 0, it means minimum point. If this one is less than 0, it means maximum point. If this one is equal to 0, it means point of inflection. So now let me show you what we are going to do. This is the y dx. The square y over the x square means differentiate the second time. So now differentiate. This one will be dy dx, the square y over the x square. Differentiate the second time. Differentiate this one the second time. This one will be 6x minus what? 4. Right? Now, look at the first one. When s is minus 2 over 3, what do we have? Like when s is minus 2 over 3, put it there. You see, for this point now, when s is minus 2 over 3, the square y over the s square will be equal to 6 multiplied by minus 2 over 3 minus 4. 3 here, 1, 3 here, 2 times minus 2, that's minus 4, minus 4. The answer is what? Minus 8. Is minus 8 greater than 0 or less than 0? Minus 8 is obviously less than 0. So when it's having less than 0, what do we have? Maximum point. So that means this one, when s is 2 over 3, it means that s equal minus 2 over 3 is a maximum point. This is a maximum point. Now, so obviously the second one will be a minimum point, but you can still confirm. Don't forget you've done the square y over the s square. Now put when s is 2. When s is 2, what do you have? The square y over the s square equals 6 times 2. Anyway, you see s put 2 minus 4. 6 times 2, 12. 12 minus 4 is 8. 8 is greater than 0. So you can see, and from what I just rub off, when the square y over the s square is greater than 0, we have minimum point. So it means that s is equal to 2 is a minimum point. So I've done classifying all those things, and I have my full 7 marks. Now 2019 question 4a. Obtain the expansion of e raised to power s and s in ascending power till you get to s raised to power 5. There are 2 ways I'm going to show you how to do it. I'm going to show you 2 ways of how you can do this. Now, the first way, add f of s e raised to power s and s. For this first way, you must already know, or you must know what exponential s is before. This expansion, this ascending power, is actually called power series. Another name they call it is Maclaurin series. Another name they call it Taylor series. Whichever one is still the same thing. They are referring to the same thing. Do you understand? So in case you see another question and they are saying you obtain the Maclaurin series, this is what they want you to do. Just pay attention. Now, you have to do something. Recall that number 1, the Maclaurin series of X. This first method I want to do is that number 1, you must know the Maclaurin series of both, or the series, the ascending power of both. Do you get? Actually, this is very simple. The Maclaurin series of e raised to power s is actually 1 plus s squared over 2 factorial plus s cubed over 3 factorial plus s4 over 4 factorial plus s5 over 5 factorial, and it goes on like that. I stop at s raised to power 5 over 5 factorial because I know that I will expand to s raised to power 5. Now the second one, sin s. The second one is sin s. Just pay attention and look at it. If you have not seen it, if you are just seeing this for the first time, this is the power series of e raised to power s, and you can just know it like that. Like, just look at it. It's very simple. You start with 1, the next one x, s squared over 2 factorial, s cubed over 3 factorial, s over 4 factorial. Do you understand? Actually, let me show you something. This is actually s raised to power 0 over 0 factorial. This is how exponential s is. This one is now s raised to power 1 over 1 factorial. Anything raised to power of 0 is 1. 0 factorial is 1. So that's why you just write 1. S raised to power 1 is 1. 1 factorial is 1. So we just write s. Do you get that? So just have s raised to power something over that in factorial. So you start from 0 and be adding, keep adding, and it's continue like that. Now sin x whole. This one is s minus s raised to power 3 over 3 factorial plus s raised to power 5 over 5 factorial minus s. So now, actually, let me write it so that you can see what is happening here. But when I want to simplify, you can see what's happening here, right? So what is happening here is that these are the Maclaurin series. In this case, this one has odd powers and the sign interchange. You see, it starts from 1, s raised to power 1 over 1 factorial. Do you get that? You will skip 2. You will skip all the even power. Go to s raised to power 3 over 3 factorial, s raised to power 5 over 5 factorial, s raised to power 7 over 7 factorial, s raised to power 9 over 9 factorial, 11, 13, like that. That is for sin s. Do you get that? Then, but what you need to also notice is that the sign is interchanging. The first one will be plus, minus, plus, minus, plus, minus, like that. It goes on like that. Do you get that? Now, let me just write cos s home too, so that although we don't need it here because obviously you can see what we have, but in case you see it in another question, cos s power series is actually 1 minus s squared over 2 factorial plus s squared over 4 factorial minus s6 over 6 factorial plus s8 over 8 factorial minus. So you can see cos s whole. Cos s is like sin x, only that cos s have even powers. This one you are even seeing is s raised to power 0 over 0 factorial. Do you get that? Anything raised to power 0 is 1. That's why we have 1. You can see this one is s squared over 2 factorial, s4, s6, s8, s10, s12. This one is even. Cos is even. Do you get that? We normally call cos an even function. So, and the sign interchange, don't forget, plus minus plus minus plus minus, and it goes on like that. Do you understand this one? Now let's come to the main business. Don't forget, this is the first method I'm showing you on how to solve this. So what we have, I have f of s to be equal to e raised to power s sin x. Multiply the two. What is that is f of s is equal to what is e raised to power s? E raised to power s is 1 plus s squared over 2 factorial plus s cubed over 3 factorial plus s4 over 4 factorial plus s5 over 5 factorial. It goes on like that. That is only e raised to power s. Now it remains sin s own. Sin s is what? Multiplied by s minus s cubed over 3 factorial plus s5 over 5 factorial. Please allow the rest to be. Don't forget, we are not expanding more than s raised to power 5. So you will expand this thing. So that's what you will do. You will expand this, and you can see everything here will expand what is here. So 1 expand all these ones. When 1 expands, 1 times all these ones. 1 times this one. So you will have x minus s cubed over 3 factorial. I'm using 1 multiply s multiply this multiply this s5 over 5 factorial, right? And then so that you don't waste your time, listen, so that you don't waste your time, once you have power that is greater than 5, don't write it, don't expand, stop expanding from there. Do you understand? Now come to the next one. S times s You know, I'm done with 1. S times S, x squared plus x times s squared, s squared. S times this one, this is minus s raised to power 4 over 3 factorial. That's what you have. Now, x times s5. You will get s6, don't write it. You have passed 5 already. Leave it. Come to the next one. S squared over 2 factorial. S squared over 2 factorial times s. It will give me s cubed over that same 2 factorial. S squared over 2 factorial times minus, don't press the minus. S squared times s cubed will give me s5. So I have s5 over 2 factorial, 3 factorial. 2 factorial, 3 factorial. S squared times s5, which will give me s7. Don't write it. Do you get that? Continue. Now I'm near in s cubed. S cubed times s. I have s4 over what? 3 factorial. Right? Pay attention. S cubed times s cubed, s6. S raised to power 6. Don't write it. Why? We pass s raised to power 5. Now from here, s raised to power 4 times s. This one gives me s raised to power 5 multiply all over what? 4 factorial, excuse me. 4 factorial. This one times s raised to power 4 times s raised to power 3. I will get s raised to power 7. Don't write it. S raised to power 5 times s. S raised to power 6. Don't write it. So I'll just write it dot. So that means that f of s expanding power series. Now check the one with the lowest s. This is x, right? S. I have s squared. There's no other s squared. You can collect like that. That's what I'm just doing. Plus s squared. S cube is here. S cube is here. S cube is here. So this 1 over 3 factorial is 6. 3 factorial is 3 times 2 times 1. That's 6. So this is minus s raised to power 3 over 6. This is plus s raised to power 3. 2 factorial, 2 times 1, 2. That is 2 factorial. So now I think I will still need this thing. The next power is s raised to power 4. I can see s raised to power 4 here, another s raised to power 4. Minus s raised to power 4 over 3 factorial plus s raised to power 4 over 3 factorial. I hope I've not made a mistake. Let me quickly cross check. I have this here s squared, s4, okay, s4, then I stop. This one s cube, okay, s5, then I stop. Then this one s4, okay. So I'm correct. So now minus s4 over 3 factorial plus s4 over 3 factorial gives 0. It's out. This one will go out. Right? So the last power is s raised to power 5. S raised to power 5 1 over 5 factorial plus s raised to power 5. S raised to power 5. 5 factorial is 5 times 4 times 3 times 2 times 1. That is 120. You can use your calculator to show that. Plus s raised to power 5. 4 factorial is 24. So f of x is equal to x plus s squared. Now this one plus this one, you can just do the LCM. 1 minus 1 over 6 plus 1 over 2. Press your calculator, you get just do LCM 6. That's minus 1 plus 6 divided by 2, 3. So 3 is this one will now give me 2 over 6, which is eventually 1 over 3. So this one will now be plus 1 over 3 s cubed. Then this one, press your calculator as well. You can easily press calculator with this 1 over 120 plus 1 over 24. But then let me just do it here. 120, I have 1 plus 5, that is 6. 6 over 120 will give me what? 1 over 20. So this is 1 over 20 s5 plus 1 over 20. That is the answer to that question. Now the second method I want to talk about alternatively, is the normal method. What if what you are given, you don't know the Maclaurin series, you don't know any series about it? You have to start crudely. Let me show you what you are going to do. F of x equal e raised to power s sin s. Let me show you the, what's it called? The power series expansion, where they say you should do power series or ascending power. This is the formula actually. F of s will be equal to f of 0. That's the first thing you write. Plus f prime of 0 over 1 factorial s. Do you see that? Plus f prime prime of 0 over 2 factorial s squared. And don't forget, we are going to s raised to power 5. Actually, what I'm writing out is called Maclaurin series. Do you get that? I'm writing out Maclaurin series. So this one is plus f123 of 0 all over 3 factorial s cubed plus f4 of 0 all over 5 factorial s4. Since I'm going to 5. So lastly, let's go to question, let's go to the last one. Let me just write it here, plus f5, that is, all this one means differentiate 5 times all over 5 factorial s raised to power 5, and it still continue like that actually. So now I have f of x. You will now be differentiating now e raised to power s sin s, right? And that's why it's marks. You can see it's either you do it this way or this other way. Then you have f of x. This f of x. Find f of 0. F of 0 will give me, anywhere you see s put 0, e raised to power 0 sin 0. E raised to power 0 is 1, but sin 0 is 0. 1 times 0, the answer is 0. So differentiate this one, f prime of x. F prime of x will be what? You know, there are two things, e raised to power s and sin s. Don't go and be using product rule here, you will waste time. Just do it like it's product rule you are using, but don't write it out explicitly. Don't be saying using product rule. How many you are going to differentiate up to 5 times? You don't have time. So take this one, e raised to power s. Differentiate this one, cos s. Do you get that? Take the first one, differentiate the second one, plus take the second one, then differentiate the first one, e raised to power s. Do you get that? So the answer will now be e raised to power s cos s plus e raised to power s sin s. Do you get that? So put 0 again, f prime of 0. See, this is what I'm looking for. F of 0, f prime of 0, f prime prime of 0. So f prime of 0. E raised to power 0 cos 0. E raised to power 0 is 1. Cos 0 is 1. 1 times 1, 1. 1 plus, obviously we know this one is 0 from here. So 1 plus 0 will give me 1. Do you see that? That's what you will do. Differentiate the second time, f prime prime of x. Differentiate this one. Take the first one, e raised to power s. Differentiate the second one, minus sin s. Right? Plus take the second one, cos s. Differentiate the first one, e raised to power s is still. If you differentiate e raised to power s, it's still the same thing. Don't forget, whenever you are differentiating exponential, I told you that whenever you are differentiating exponential, the power, differentiate the power, the answer is 1. Write the question, e raised to power s. So 1 times e raised to power s is still e raised to power s. So that's why if you differentiate e raised to power s, you have this. Plus, now this one, you differentiate e raised to power s sin s. You know, when I have e raised to power s sin s, when I differentiated, this was the answer I got. This is the answer I got, e raised to power s cos s plus e raised to power s sin s. So minus e raised to power s sin s plus e raised to power s sin s. The answer is 0. I'm left with this one and this one. This one will become 2 e raised to power s cos s. So you will now do f prime prime of 0. This is 1. This is f prime prime of 0. This is 1. N raised to power 0 is 1, but 0 is 1. The answer is 2. Do you get that? You will differentiate the third time. So this is of x. Just keep these two. E raised to power s cos s. see, e raised to power s cos s, when we differentiate, this is the answer we got. We got minus e raised to power s sin s plus e raised to power s cos s. So put 0 there. 1, 2, 3 of 0. This one will be 0 because sin 0 is 0. This one will be 1. So 2 times 1. The answer is 2. You get that? Now the fourth one, after the fourth one, then the fifth one, then we are done. F4. Do as if minus is not there. If you differentiate e raised to power s sin s, this is e raised to power s sin s. Differentiate, what do you have? You have this e raised to power s cos s plus e raised to power s sin s. Differentiate e raised to power s cos s. See, when I have e raised to power s cos s here, this is the answer I got. I got minus e raised to power s sin s plus e raised to power s cos s. That's what I got, right? So let me open the bracket. This is minus e raised to power s cos s minus e raised to power s sin s minus e raised to power s sin s plus e raised to power s cos s. So minus e raised to power s cos s plus e raised to power s cos s is out. That's 0. I'm left with these two things. This one plus this one will give me minus 2. So this is minus 4 e raised to power s sin s. So if you do f4 of 0, n to the raised power of 0 is 1, but sin 0 is 0. So this is just minus 4. Then lastly, f5 of s. So this is minus 4. Differentiate e raised to power s sin s. Differentiate e raised to power s sin s. This is the answer. E raised to power s cos s plus e raised to power s sin s. That is the answer. So f5 of 0. This one will be 0 because sin 0 is 0. Because 0 is 1, e raised to power, this one is 1. Minus 4 times 1. Minus 4. And that is the answer I. This is rubbish. F4. If it, this is 0, 0. 0 times anything is 0. Now, so let me just put in the values. So I just need to put in the values, and then I've gotten the series I'm talking about. Don't let me rub off this answer I have here so that you see that they will be the same thing. So now, f of s will be equal to f of 0. F of 0 is 0. I don't need to write it. F prime of 0 is 1. 1 over 1 is 1. So 1 times s, s. F prime prime of 0. The answer is 2. 2 factorial is 2 times 1. The answer is 2. S squared. F prime prime of, I have 2 again, plus 2. 3 factorial is 3 times 2 times 1. The answer is 6. I have s cubed. F4 is 0. 0 times anything is 0, so I don't need to rewrite it. F5 is minus 4. So this one will be minus 4 over 120. 120 is 5 factorial. 4 factorial, 5 factorial is 120. So s raised to power 5, then dot dot dot. So f of x will be equal to x plus 2 divided by 2 is 1, so I'm having s squared. This is 1 over 3 s cubed because 2 here, 1, 2 here, then this is minus 1 over 30. 4. So I have 1 over 30 here. Minus 1 over 30 s5. Something is wrong somewhere. Is that there's a mistake in this place? Is that this one is wrong, or my f5 is not correct? Let me check. So I got f4 to be this minus this is 0, this one is minus 2, this is minus 4 e raised to power s sin s. If you put 0 here, the answer will be 0. E raised to power s sin s. I have e raised to power s cos s plus e raised to power s sin s. If you put 0 here, this one is 0. If you put 0 here, this one is 1. The answer is minus 4. Minus 4 over 5 factorial. 5 factorial is 120. 4 divided by 120 is 4 divided by 120 is 30. Minus 1 over 30. So I suppose there is a problem here. Maybe I did not expand it. I did not expand that other one way, and I don't want to go back. So I think it remains one more question to solve here. So in reality, let me show you the last one, 2018. Question number 4A. 2018 question number 4A. They say show that y equal a cos s plus b sin a is a solution of the differential equation this. Now I have y to be equal to a cos s plus b sin s. If I want to show that this is the solution, I just differentiate. Differentiate 2 times, then add y to it. You see that you get 0. So differentiate this one the first time. The y ds. A and B are constant too. Differentiate cos, you have minus sign. So I have minus a sin s. Differentiate sin, you have cos s. Differentiate the second time, this square y over the s squared. This is minus a cos s minus b sin s. I just differentiated. Differentiate this cos, you have minus sign. So what is this square y over the s squared plus y? The square y over the s squared, that is minus a cos s minus b sin s, then plus y plus a cos s plus b sin. Minus a cos s plus a cos s 0. Minus b sin s plus b sin s 0. So the answer is see that the square y over the s squared plus y equals 0. So thus y is the solution of differential equation. Therefore, y equal a cos s plus b sin s is the solution of the what differential equation. And that's all.